Graphing quadratic function in vertex form. When you graph a parabola, it goes down to the vertex, then turns and goes back up. This allows symmetric points on either side of the axis of symmetry. If you have a parabola that's turned downward, it goes up, then turns at the vertex and goes down. And you have symmetric points on either side of the axis of symmetry. Vertex form of a quadratic function. Let f of x equal a parenthesis x minus h close parenthesis square plus k, where a does not equal 0. Then f is a quadratic function and its graph is a parabola. We say the equation is in vertex form. Graphs of quadratic functions of the form f of x equals ax squared. F of x equals x squared. If we were to create an x f of x table, we could pick some values for x, find f of x, and then plot our equation. So let's use 3, 2, 1, 0, -1, -2, and -3. 3 squared is 9, so I have the point 3, 9. 2 squared is 4, so I have the point 2, 4. 1 squared is 1, so I have the point 1, 1. 0 squared is 0, so I have the point 0, 0. -1 squared is 1, so I have the point -1, 1, which is symmetric to 1, 1. -2 squared is 4, so I have the point -2, 4, which is symmetric to +2, 4. Then I have -3 squared, which is 9, which is symmetric to the order pair 3, 9. 0, 0 is my vertex. And now I have my parabola. This is the basic form for all of our parabolas. In this example, compare the graphs of f of x equals x squared, g of x equals 2x squared, and h of x equals 6x squared. We need to go to our graphing calculator. So going to y equals, we want to start with f of x, which is x squared. For y2, we'll type in g of x, which is 2x squared. For y3, we'll type in h of x, which is 6x squared. Now we're ready to graph. Our blue curve is f of x, our green curve is g of x, and our brown curve is h of x. Our value of a, which is in front of the x squared, went from 1 to 2 to 6. As the number got larger, my graph became more narrow. As the value of a increases, the narrower the graph becomes. In this example, compare the graphs of f of x equals x squared, g of x equals 1/2 x squared, and h of x equals 1/4 x squared. First, we need to look at their graphs. Going to y equals, type in x squared. Then for y2, we want our g of x, which is 1 divided by 2, x squared. Then we want to type in for y3, h of x, which is 1 divided by 4, x squared. And now we're ready to graph. Our blue graph is f of x equals x squared. The green graph is g of x equals 1/2 x squared, and our brown graph is h of x equals 1/4 x squared. As the number in the denominator of our fraction becomes larger, the wider our graph becomes. As the value of a decreases, the wider the graph becomes. In this example, compare the graphs of f of x equals x squared, g of x equals negative 3x squared, and h of x equals 3x squared. So going to our calculator, y equals, our y1 will be x squared, our y2 will be our g of x, which is negative 3x squared, and then our h of x is 3x squared. Now we're ready to graph. So our blue graph is y equals x squared. Our green graph is y equals negative 3x squared. And our brown graph is y equals 3x squared. Because of the 3, our graph is narrower. The negative in front of the 3 flipped my brown graph to become my green graph. So if you have a negative in front of your A, it's going to cause the graph to open downward instead of upward. The graph of f of x equals negative ax squared is a reflection over the y-axis of f of x equals ax squared. Graphing quadratic function in vertex form. Graphs of quadratic functions of the form f of x equals ax squared. For the function of the form f of x equals ax squared, the graph is a parabola with vertex 0, 0. If the absolute value of a is a large number, then the parabola is steep. It is narrow. If a is near 0, then the parabola is not steep, it is wide. If a is greater than 0, then the parabola opens upward. If a is less than 0, then the parabola opens downward. The graph of y equals negative a squared is the reflection of the graph of f of x equals ax squared across the x-axis. In this example, compare the graphs of f of x equals x squared, g of x equals x squared plus 2, and h of x equals x squared plus 5. Going back to our calculator, going to y equals, we have our x squared. Go down and we want to type in x squared plus 2. Moving down, x squared plus 5. Now we're ready to graph. Going to trace. For my y equals x squared, my blue graph, my vertex is at 0, 0. If I push my up arrow, it's now on the graph of x squared plus 5. Notice my vertex is 0, 5. I push my up arrow again, and now I'm on the graph of y equals x squared plus 2, and my vertex is 0, 2. So when I add a number to x squared, my graph is moved up on the y-axis. The graph of f of x equals x squared plus k translates or moves the graph up the y-axis. For this example, compare the graphs of f of x equals x squared, g of x equals x squared minus 2, and h of x equals x squared minus 5. Going back to our calculator, go to y equals. My first plot is x squared. I'm going to arrow down to my second my y2, and I'm going to change this to x squared minus 2. Then I'm going to do the same thing for y3, changing my plus to a minus. Graph. Trace. Again, my vertex for y equals x squared is 0, 0. My vertex for y equals x squared minus 2 is 0, negative 2. And my vertex for y equals x squared minus 5 is 0, negative 5. So subtracting a number from x squared moves the vertex down the y-axis. The graph of f of x equals x squared minus k translates or moves the graph down the y-axis. In this example, compare the graphs of f of x equals x squared, g of x equals, in parentheses, x plus 2 squared, h of x equals x plus 5 parentheses squared. On our calculator, we return to y equals. My y1 is x squared. For y2, parentheses, x plus 2, close parentheses, squared, down to y3, parentheses, x plus 5, close parentheses, square. And now we want to graph. Go to trace, and the vertex of y equals x squared is 0, 0. Up arrow, that takes me to y equals x plus 5 squared. Up arrow. Okay, there's my cursor, and I'm going to keep moving it until I'm at the vertex. So my vertex here is negative 5, 0. If I press my up arrow, it'll take us to y equals x plus 2 squared. Based on where the cursor is, this time I want to go to the right. This is as close as we can get to the vertex if you round to the nearest whole number. It's negative 2, 0. When you add a number to x before it's squared, it will move your graph to the left. The graph of f of x equals parentheses x plus h, close parentheses squared, translates or moves the graph left on the x-axis. In this example, compare the graphs of f of x equals x squared, g of x equals parentheses x minus 2, close parentheses square, and h of x equals parentheses x minus 5, close parentheses square. Going back to our calculator, go to y equals, and arrow down, and change my plus sign to a minus sign, and arrow down, and change my plus sign to a minus sign. Graph. Trace. Y equals x squared has a vertex of 0, 0. Use my up button. And now I am on the graph of y equals x minus 5 parentheses squared. I'm going to go to the right. Until my cursor's at the vertex, which is 5, 0. Up. This time I'm going to go to the left. And again, it's not giving me the exact answer, but rounding to the nearest whole number, I have 2 for x and 0 for y. So my graph is moved to the right when I subtract a number from x before it is squared. The graph of f of x equals, in parentheses, x minus h squared translates or moves the graph right on the x-axis. Three-step method of graphing a quadratic function in vertex form. To sketch the graph of f of x equals a, open parenthesis, x minus h, close parenthesis, square, plus k, where a does not equal 0, Number 1, sketch the graph of y equals ax squared. Step 2, translate the graph from step 1 to the right by h units if h is greater than 0, or to the left by the absolute value of h units if h is less than 0. Step 3, translate the graph from step 2 up by k units if k is greater than 0, or down by the absolute value of k units if k is less than 0. In this example, graph the function by hand. F of x equals negative, open parenthesis, x plus 3, close parenthesis, squared. First, we want to compare it to the formula for a parabola. A is what's in front of my parenthesis, so A equals negative 1. H is the opposite sign of the number in the parentheses with x. Since I have x plus 3, H is negative 3. K is whatever is added on to the end. Since I don't have anything, K is 0. Start by graphing y equals x squared. We have our points at negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Since h is negative 3, we want to take each of those points and move it 3 places to the left. Starting with negative 3, 9, I want to go 3 places to the left. Then negative 2, 4. Negative 1, 1. Zero, 0. One, 1. Two, 4. And 3, 9. So we draw our new graph on these dots. Then we need to flip it because a is negative 1. So now we have the graph of f of x equals negative, parenthesis, x plus 3, close parenthesis, squared. For this example, graph the function by hand. F of x equals x minus 4, parenthesis, squared, minus 3. Again, using our formula for a parabola, a is 1, h is 4, and k is negative 3. Starting with y equals x squared, this time my graph is not going to flip, be narrower or wider, but I will need to move all of my points 4 to the right. So 0, 0 becomes 4, 0, 1, 1 becomes 5, 1, negative 1, 1 becomes 3, 1, 2, 4 becomes 6, 4, negative 2, 4 becomes 2, 4, 3, 9 becomes 7, 9, and negative 3, 9 becomes 1, 9. Draw our new graph. Now we need to take those points and move them down 3 places. So 4, 0 becomes 4, negative 3, 3, 1 becomes 3, negative 2, and 5, 1 becomes 5, negative 2. 2, 4 becomes 2, 1, and 6, 4 becomes 6, 1, and 1, 9 becomes 1, 6, and 7, 9 becomes 7, 6. Then we draw our parabola. And now we have the graph of the function f of x equals parenthesis x minus 4 close parenthesis squared minus 3. Vertex of a quadratic function. The vertex of a quadratic function in vertex form f of x equals a parenthesis x minus h squared plus k is the point hk. In this example, graph the function by hand, find the vertex. F of x equals 3 parenthesis x plus 2 close parenthesis square minus 6. Comparing it to our formula for a parabola, a is the number in front, which is 3. H is in the parentheses with your x, but the opposite sign, so it's negative 2. K is added onto the end, so that's negative 6. That means that our vertex is negative 2, negative 6. To graph, we want to start with y equals x squared. Starting with the fact that a equals 3, I know my graph is going to be more narrow. So plotting my main points, if x is negative 2, normally y is 4. Since a is 3, I want to take my answer and multiply it by 3. 4 times 3 is 12, which is going to be up here. Since it's off my graph, it's just an estimate. Normally, when x is negative 1, y is 1, but 1 times 3 is 3. When x is 0, y is 0. 0 times 3 is 0. When x is 1, y is 1, but 1 times 3 is 3. And when x is 2, y is normally 4, but 4 times 3 is 12. Again, this is off my graph, so I'm just estimating. Now I'm ready to draw my new parabola. Now I want to look at how h is going to change my graph. I'm going to move my graph 2 to the left. So 0, 0 becomes negative 2, 0. 1, 3 becomes negative 1, 3. And negative 1, 3 becomes negative 3, 3. Now I'm ready to draw my next parabola. Now I need to move my points down the y-axis by 6. So negative 2, 0 becomes negative 2, 6, which is what we said was going to be our vertex. Negative 1, 3 is now going to be negative 1, negative 3. And negative 3, 3 is now going to be negative 3, negative 3. Now I'm ready to draw my final parabola. So this is the graph of f of x equals 3 parenthesis x plus 2 close parenthesis squared minus 6. In this example, graph the function by hand, find the vertex. F of x equals negative 2 times x minus 5 parenthesis squared plus 3. I need to compare that to my formula for the parabola. From that, I can tell that my a is negative 2, my h is 5, and my k is 3. So this tells us that our vertex is 5, 3. To graph, start with y equals x squared. My first step is to make this graph narrower. Since a is negative 2, I need to multiply all my y coordinates by 2. So that's going to give us negative 2, 8, negative 1, 2, 0, 0, 1, 2, and 2, 8. So now I'm ready to draw my new parabola. Now that it's narrower, I can flip it. So my vertex is still 0, 0, Now I have a point at -1, -2, 1, -2, at -2, -8, and 2, -8. Now it's time to look at my h, which is 5. That means each of these points are going to be moved to the right by 5. So instead of 0, 0, I have 5, 0. Instead of 1, -2, I have 6, -2. Instead of -1, -2, I have 4, -2. Instead of 2, -8, I have 7, -8. And instead of -2, -8, I have 3, -8. Now I'm ready to draw that parabola. Now looking at the k, it's going to move up by 3. So instead of 5, 0, it's 5, 3, which is what we found to be our vertex. Instead of 6, -2, it's 6, 1. Instead of 4, -2, it's 4, 1. Instead of 7, -8, it's 7, -5. And instead of 3, -8, it's 3, -5. Now we're ready to draw our parabola. So this is the graph of f of x equals -2 parenthesis x minus 5 close parenthesis squared plus 3. In this example, graph the function by hand. Find the domain and range of the function. f of x equals 2 parentheses x plus 2 close parenthesis square minus 1. Comparing it to our equation for a parabola, my a is 2, my h is -2, and my k is -1. Begin with the graph of y equals x squared. We want to take our points and see what they would look like if a was 2. -2, 4 would become -2, 8, because 4 times 2 is 8, which means I also have 2, 8 since they're symmetric. -1, 1 would become -1, 2, which means I would have 1, 2 since it's symmetric, and 0, 0 would remain the same. And now I can graph my new parabola. Now that I have this parabola, I want to move my parabola 2 to the left, since h is -2. So 0, 0 becomes -2, 0, -1, 2 becomes -3, 2, 1, 2 becomes -1, 2, -2, 8 becomes -4, 8, and 2, 8 becomes 0, 8. Graph my new parabola, and now I'm ready to look at k. Since k is -1, they're all going to move down 1. So -2, 0 is -2, -1. -3, 2 is -3, 1. -1, 2 is -1, -1. 0, 8 becomes 0, 7. And -4, 8 becomes -4, 7. Now we're ready to draw the new parabola. And now we have the graph of f of x equals 2 parentheses x plus 2 squared minus 1. Now we need to find the domain. Our vertex is -2, -1. There's not a value for x that I can't substitute into my f of x equation. So my domain is all real numbers. For my range, however, since my vertex is the only point that isn't symmetric, this is the smallest value I'm going to have on my y-axis. So my range is y is greater than or equal to -1. Anytime your parabola opens up, the y value of the vertex will be the smallest value for y. In this example, graph the function by hand. Find the domain and range of the function. f of x equals negative 3 parenthesis x plus 4 squared plus 2. Comparing it to the formula for our parabola, my a is negative 3, my h is negative 4, and my k is 2. Start with my graph of y equals x squared. I want to take the y values and start by multiplying them by 3. This does nothing to my vertex, but for 1, 1, I end up with 1, 3, and negative 1, 3 because they're symmetric. 2, 4 becomes 2, 12, and negative 2, 12 because they are symmetric. Graphing, that narrows my parabola. Now taking into account for my negative 3, moving to my h, since it's negative 4, I'm going to move to the left, 4. So 0, 0 becomes negative 4, 0. Negative 1, negative 3 becomes negative 5, negative 3. And 1, 3 becomes negative 3, negative 3. Graphing, I get my new parabola. Using the fact that k is 2, I'm going to move up 2 on the y-axis. So negative 4, 0 becomes negative 4, 2. Negative 3 becomes negative 3, negative 1. And negative 5, negative 3 becomes negative 5, negative 1. So now I have my new parabola. And this is my graph for f of x equals negative 3, open parenthesis, x plus 4, close parenthesis, square, plus 2. Because this is a parabola, my domain will be all real numbers. Looking at my vertex, it's negative 4, 2. Because my parabola is pointing down, my largest value of y will be the vertex, which is 2. So my range is y is less than or equal to 2. Anytime your parabola points down, the y value of your vertex will be the largest value for y. Graphing quadratic function in vertex form. The vertex of a quadratic function in vertex form for f of x equals a parentheses x minus h parentheses squared plus k is the point hk. To graph your function, sketch the graph of y equals ax squared. A will determine how narrow or wide your graph is. Also, if it opens upward or downward. If it opens up, A is positive. If it opens down, A is negative. Translate the graph from step 1 by h. If h is positive, move it to the right. If h is negative, move it to the left. Translate the graph from step 2 by k units. If k is positive, move it up. If k is negative, move it down. If your parabola opens upward, the domain will always be all real numbers. Your range, k, will be the smallest value of y. So it will be y less than or equal to k. If your parabola opens downward, the k value of your vertex will be the largest value of y. So your range will be y is greater than or equal to k.